All right, let's dive right into this explainer. Today, we're tackling one of the absolute ultimate existential mysteries of our time. We're going to look at that exact messy boundary where theoretical computer science crashes headfirst into philosophy. And, well, it all revolves around one single, completely mind-bending possibility. Are we living in a computer simulation? You know, it's a question you hear pop up literally everywhere. Popular culture, tech forums, those late-night dorm room debates. Are we just lines of code running on some trans-dimensional teenager's computer? Is this entire reality just a digital construct? And honestly, more importantly, if we are living inside a simulation, how would we actually know? Like, would there be hard evidence?
Well, for a lot of working scientists, this whole simulation hypothesis can feel like a pretty frustrating distraction. Renowned computer scientist Scott Aronson humorously points out, maybe I'll add this as number 4,385 on the worry list. He argues that if we can never, ever empirically tell the difference between a real universe and a simulated one, the hypothesis is really just another theoretical anxiety. In fact, he points out that theologians have actually been debating these exact same eternal imponderables for centuries. Are you being dreamed up in the mind of God, or are you just being executed in a Python script? If it doesn't change a single thing about how you live, maybe it really does belong at the absolute bottom of the worry list.
But hang on, what if we actually could find proof? Let's move to our next section, searching for empirical evidence, or looking for the blue screen of death. Aronson actually jokes about some obvious glitches we might see, like the stars suddenly rearranging themselves into a giant error message, or a literal Windows blue screen of death plastered right across the sky, or even a voice from a burning bush telling researchers to free humanity from our digital bondage. If that happens, well, yeah, of course we update our worldview. But short of that happening, actual scientific progress involves testing our current physical theories. For instance, when physicists try to put certain really complex particle behaviors, like chiral quantum field theories, onto a simulated computer grid to study them, they hit massive roadblocks. They get these weird extra symmetries they definitely don't want. So pushing against these computational limits might be exactly where we finally find the edges of our reality's programming. And this brings us to a massive scientific question about the fundamental hardware of our reality in our next section, the universe as a computer, the ultimate limits of physics. Ultimately, what we really want to know is if the final theory of physics, whether that's quantum gravity or whatever it ends up being, can actually be simulated probabilistically on a computer to any desired accuracy. This is known as the physical Church-Turing thesis. Aronson points out that his personal belief, which is informed by the deepest things we've learned about the very smallest scales of reality, like the Planck scale and the thermodynamics of black holes, is a resounding yes. These discoveries strongly suggest that the physical universe really is, in some very real sense, a giant Turing machine. And this brilliantly illustrates a point brought up in a fascinating discussion by a commenter named Artemium. Think about modern video games for a second. They use these neat tricks like low-res skyboxes to fake distant stars and mountains, just to save on computing power. Well, if a hyper-advanced civilization constructed our simulation, they wouldn't necessarily need the completely obscene computing power to simulate every single atom of every faraway galaxy. They might just use the physical equivalent of 3D game design techniques. Basically, they'd be cutting corners to render a low-resolution approximation of distant space, and only rendering it in high detail if a human actually happens to look through a telescope. So with that physics in mind, let's move to our next section, the ancestor simulation problem, Bostrom's famous argument. Let's systematically tear down philosopher Nick Bostrom's famous argument that claims we are almost certainly already simulated. The original intuition seems incredibly mathematically compelling at first glance. The logic goes like this. First, our future descendants acquire massive computing power. Second, they run trillions of simulations of their ancestors. And third, statistically speaking, we are vastly more likely to be one of the trillions of sims than the one true base reality. The argument is that simulating 10 to the 20th power humans in the year 2024 is just absolute computing chicken feed for a future civilization. Because they could run millions or trillions of these ancestor simulations, sheer statistics suggest that you and I should expect that we almost certainly are sims. Now, what's really fascinating about Aronson's pragmatic objection here is that it essentially saws right through the branch it's sitting on. Why? Well, because the computer must physically fit inside its host universe. Any simulated universe run by our descendants would have to be smaller than ours, requiring fewer bits and operations to describe it. So if we are in a simulation, our host universe must be massively bigger than ours.
This means it wouldn't be our own descendants simulating us at all. It would be some kind of unimaginable beings living in a much larger universe. You literally cannot have an infinite chain of identical simulations, which severely undermines the whole simplicity of Bostrom's original intuition.
But even if a host universe possesses that sheer computing power, how do we account for the great mystery of the human mind? Let's look at our next section. What about human consciousness, the hardware of the mind? The theorists fiercely debate this one. Roger Penrose and Stuart Hameroff believe there is uncomputable physics happening at the quantum level in the brain's microtubules, which basically means a standard computer couldn't ever generate consciousness. Meanwhile, biologist John Joe McFadden proposes consciousness is an electromagnetic field produced by synchronous neuron firing. But Aronson notes a massive loophole here. Even if physics is uncomputable, like Penrose claims, our host universe could simply be running on uncomputable physics too. I mean, what are impossible computational limits to a godlike simulator, right? Pointing to the physical mechanisms of consciousness in our brains doesn't disprove the simulation hypothesis at all, because a perfect simulation of those exact mechanisms would yield exactly the same results. So the absolute crucial point is this. If we can't definitively prove it either way through particle physics or consciousness, does this debate have any actual value at all? Welcome to our final section, Does It Even Matter? The philosophical showdown. This brings us to a truly fantastic clash of perspectives. On one hand, Aronson leans heavily verificationist. He demands to know how knowing we are in a simulation would actually change our lives. If a question has absolutely no empirical consequences, he thinks it might just be a bad scientific question. But on the flip side, philosopher David Chalmers steps in to argue the exact opposite. Chalmers quips that the very lack of empirical consequences is exactly what makes it a good philosophical question. For him, the lack of testability is absolutely a feature, not a bug. Chalmers defends this with a really fascinating concept he calls the simulation repost. He argues, suppose we're the ones running the simulation. It seems clearly meaningful to say that the beings in the simulation are indeed in a simulation. Think about it. If we eventually built a perfect simulation of a world, the fact that those digital beings are simulated is an objective, undeniable truth to us. It doesn't matter one bit if the simulated beings themselves can never test it or perceive it. Unless you want to completely deny the existence of absolute, observer-independent truth, you kind of have to admit that the simulation question is objectively meaningful. In response to this philosophical showdown, Aronson builds a bridge between the two extremes by coining a brand new category for the specific type of thought experiment. He calls it a pre-meaningful question. So what is that? Well, a pre-meaningful question sits in this state of intellectual purgatory. It has no empirical consequences for how we live or what we expect to see. It's neither entirely meaningful nor totally meaningless. Instead, a pre-meaningful question demands a sort of toll before you can discuss it. It requires an observer to first justify why it matters based on their specific philosophical views, before we can even begin to debate its truth. Is the simulation hypothesis simply a pre-meaningful question? Honestly, perhaps that is the ultimate takeaway here. Until the stars literally rearrange themselves into a giant error message or a burning bush drops the universe's source code right in our laps, maybe we should accept the simulation hypothesis as the ultimate pre-meaningful puzzle. It forces us to examine the very limits of computation, consciousness, and physics. But it leaves us with one final, totally undeniable question. If you found out tomorrow that your entire life was just a line of code, what exactly would you change about how you live today?